One thing that very frequently comes up when programming, no matter which language, is the need to compare your variables or some kind of objects. So let's look at how we do that. Now in Java, it's a little different if you're from various other programming languages. And there are a few gotchas that you need to watch out for. And what I'm going to show you in this lecture is the more correct way to do things as of the latest JDKs. So let's have two integers. Integer a is equal to 9 and integer b is equal to 9 as well. And how do we compare these? We use what's called an if statement, and then in brackets I'm going to show you the older way of comparing things. If a is equals to b, open your curly brace and close it. And then inside of here we can have our system.out.println, and we will send ourselves an equal message back. So what this line does is compare a to b, and if they're the same value, and there's a bit more to it than that, but for now just think about it in that way, then I would like you to print out equal. So if we compile that and then run it, we now get our equal printed out. Now what if they're not the same? Well, we can have an else statement that goes hand in hand with if. And we open our curly brace and close it. And again, we can have system.out.println to tell ourselves not equal. And then let's change the value of b to be 93, compile, and run. And now we get numbers are not equal. Now, what if we want to go the other way round? So we want to check if a is not equal to b. Well, this is simple enough. Instead of two equal signs, we have an exclamation and then an equal sign. And that simply means not equal to. Generally, in programming, when you find an exclamation mark, it means not. And so here we can type not equal exclamation. I really can't spell exclamation or equal. And if we compile and run that, we will get not equal exclamation. So that's how you check for equality and non-equality with numbers such as integers or doubles or floats. But what about strings? Well, let's turn these into strings and another string, and let's call this my name, and let's have the other one as my name. Now let's try and compile this. That's fine. Run it, and it tells us that these strings are equal. Now there's a little gotcha here. When we are programming in Java and we're using string equalities, we do not want to use this notation. I won't go into why, because that doesn't really matter here. I'm simply trying to give you a jump start in the Java world. So when it comes to comparing strings, we should use a dot equals and then in brackets b. And what this does is get the actual value from b and compare it to the value of a. It may seem the same as with the equals signs, but in the background it's not really. And to avoid errors in your programs, always use this notation for your string. So now I'll compile that and run it. And it tells us, oh, we have a slight error in my logic there, not equal, because I've changed the logic into equals instead of not. And let me put not equal here. Let me recompile that and run it, and they are both equal. Okay, now what if we want to check if these values are not equal, and then we want to add a further check down the line? Well, we can do something like this. So the first one says equal, and then underneath of the first if statement, we can have another else if. So we can check something else. And for example, we could say if A or exclamation A dot equals B, and that means A does not equal B, then we can perform another function. So system.out.println not equal, and then we can have an else that gives us a default statement or execution. Now what this is doing is comparing equals here, and then it's saying if this doesn't work out, then come to the next one, and if A doesn't equal B, then do this, but if that doesn't work out, then come down to this one. So it kind of goes down in a little systematic process, checking which one it should run. And you can have as many if-else statements as you like, all chained up together. So if I put grant 2 up there, hit compile and run, I have not equal. So it skipped the first one, found this one is true, so it skips the rest of them. Now in this case it doesn't make sense to have 3 because either they're equal or not, but in other cases you will have a need for this. For example, if you're trying to compare some user input that's come back and you want to compare 10 things that could come back, you would use something like this. However, it starts to get a little messy and the program tends to run on if you have lots of if-else statements all chained up. So there's an alternative for comparisons in Java, and that is a switch case statement. So let's remove all of this if-else code. Let's also remove string b and create a simple integer a, which will be equal to 4. Now we can create our switch statement. So we do that by switch, open brackets, and we pass it over our integer. Then we open some curly braces and close them. Inside of those curly braces, we start to define cases. So if we have a case where our integer a is equal to 3, we put a colon in, and then we write some code to execute. So we'd put something like system.out.println 3. And then after that, and this is optional, we put a break statement, and that tells us to stop executing this case. We can also have a case whereby integer is 4, and we can put a system out println that returns 4. And of course, we can break out of that once it's done. So we can have as many cases as we like, and it's advisable to have a default case, and this you define by default, and this will be system out default, and then we break out of that one. So let's compile that and then run it, and it tells us our system out is 4. So those are switch case statements, and if you ask me, they're a little bit neater, a little bit more organized than if-else statements, but those two methods together provide all of the comparison power that you need inside of Java.